Welcome to the Introduction to Modemulator video. The topics I'll cover in this video are: what is a modemulator? What are the target applications? How Modemulator works? The graphical user interface software, and some online resources. So, what is a modemulator? The word modemulator is a mashup of the phrase modem emulator, which describes a cellular gateway that has the same Hayes command line interface that an analog modem has. Physically, a modemulator is a US Robotics cellular gateway with a US Robotics modemulator expansion card installed. The intended target application for modemulator is legacy dial-up or lease line data communication systems. I'll illustrate a dial-up data communication system in the following diagram. The target system has a centrally located host processor running legacy software that communicates with an analog modem over an RS-232 serial interface, and the modem connects to the public switched telephone network using plain old telephone service. One or more remote sites have a processor running legacy software that communicates with an analog modem over an RS-232 serial interface, and the modem connects to the telephone network using plain old telephone service. A communication system that uses analog modems and the telephone network is classified as a peer-to-peer communication system, in which the network allows either end to initiate or answer a connection, and the modems can initiate or answer without being reconfigured. Now, let's briefly review the operation of a dial-up data communication system. When the host software initiates a connection to a remote site, it sends a dial command to the host modem. The dial command contains the phone number of the remote site. Then, if the telephone network is available, the remote modem normally sends a ring indication to the remote processor. The host modem may send a confirmation back to the host software, indicating that the connection is proceeding. If the network isn't available, the host modem will send a busy or no dial tone or no carrier message instead. Then the remote software normally sends an answer command to the modem, or in some cases the modem may auto-answer. The connection will then complete, and both modems will notify their respective processors. The software can then transfer data bidirectionally. Alternatively, in a peer-to-peer system, the remote software can initiate a connection to the host, and the same steps will occur, but in the opposite direction. There are many good reasons to convert a dial-up data communication system to cellular. Let's see what's normally involved in converting a legacy dial-up system to cellular. First, the telephone system is replaced by cellular data service, and the remote analog modem is replaced by a cellular modem or gateway. Here's where the similarity ends. Cellular data networks are intended to connect with the host processor over the internet using an Ethernet interface, not over a cellular modem to a serial interface. This type of system is classified as a client-server communication system, in which only client endpoints can initiate a connection and only server endpoints can answer a connection. To learn more about the operation of cellular networks and cellular modems, please watch the Understanding Cellular Data Connectivity for M2M video at the US Robotics channel on YouTube. The legacy software running on a remote processor will try to initiate a connection by sending a dial command to the cellular modem, but cellular modems and gateways don't respond to a dial command. Also, the legacy software expects a ring indication to signal an incoming connection, but cellular modems and gateways don't send a ring indication. The host software expects to communicate with an analog modem over a serial interface, not over an Ethernet interface to the Internet. To solve these incompatibilities, the legacy software at every remote site must be replaced if new software is commercially available. The new software will probably require a hardware upgrade as well. Also, the host software must be reconfigured or replaced so it can connect using Ethernet protocols. And that may require a hardware upgrade too. As you can see, converting a legacy dial-up system to cellular can require a major overhaul. The US Robotics Modemulator can upgrade a legacy dial-up system to cellular without replacing all the legacy software and hardware. Let's take a look at the Modemulator's main features and functions that allow it to upgrade many types of legacy dial-up systems to cellular. First, we'll examine Modemulator peer-to-peer operation that emulates the behavior of analog modems and telephone networks. Then I'll show you the direct IP dialing feature that can be used for very large systems or for cases where it is possible to update the dial command within the legacy software. Next, I'll explain the automatic switchover feature that allows the gradual conversion of a legacy system to cellular or supports a permanent mix of cellular and dial-up sites. Then I'll illustrate a system that uses Modemulator's single-ended mode so that a legacy remote site can communicate with a networked host. Finally, I'll describe how a Modemulator can be repurposed as a conventional cellular gateway once a system has been fully overhauled. First, peer-to-peer operation. Peer-to-peer Modemulator operation is used to upgrade a legacy dial-up data communication system with a drop-in replacement of the analog modems by Modemulators and replacement of the telephone network by a private peer-to-peer cellular network. For more information about private peer-to-peer cellular networks, please watch the Understanding Cellular Data Connectivity for M2M video on the US Robotics channel on YouTube. A peer-to-peer Modemulator system can continue to use the original application software by emulating the behavior of a dial-up network. For example, when the host software initiates a connection to a remote site, it sends a dial command to the host Modemulator. The dial command contains the legacy phone number of the remote site. The Modemulator will search for that phone number in its user-programmed dialing directory, which is a lookup table that translates the phone number into an IP address and port number. Then, if the network is available, the remote Modemulator normally sends a ring indication to the remote processor, just as an analog modem would. The host Modemulator may send a confirmation back to the host software, indicating that the connection is proceeding. If the network isn't available, the host Modemulator will send a busy, or no dial tone, or no carrier message instead, just as an analog modem would. Then the remote software normally sends an answer command to the Modemulator, or in some cases the Modemulator may auto-answer. The connection will then complete, and both Modemulators will notify their respective processors, just as analog modems would. The legacy software can then transfer data bidirectionally. Please note that some legacy software that was designed to work with dial-up modems and telephone networks may not tolerate the timing latency that's inevitable in packet-switched cellular networks. It's strongly advised that you perform a proof of concept to test your legacy software for sensitivity to timing latency. Since the Modemulator system is peer-to-peer, the same steps can occur in the opposite direction when the remote software initiates a connection. Next, I'll explain the direct IP dialing feature. The Modemulator's dialing directory is a user-programmable lookup table that allows the Modemulator to translate phone numbers into IP addresses and port numbers. If the system must contact more than 7,200 remote Modemulators, or for cases where it's preferable to update the dial command in the legacy software instead of translating it within the Modemulator, the dialing directory can be bypassed by using the direct IP dialing. When the host software initiates a connection to a remote site, it sends a dial command to the host modemulator. This dial command contains the destination IP address and port number instead of a phone number. The modemulator will attempt to connect to the IP address and port number. Then, if the network is available, the remote modemulator normally sends a ring indication to the remote processor, just as an analog modem would. The host modemulator may send a confirmation back to the host software, indicating that the connection is proceeding. If the network isn't available, the host modemulator will send a busy, or no dial tone, or no carrier message instead, just as an analog modem would. Then the remote software normally sends an answer command to the modemulator, or in some cases the modemulator may auto-answer. The connection will then complete, and both modemulators will notify their respective processors, just as analog modems would. The legacy software can then transfer data bidirectionally. Next, I'll explain the automatic switchover feature. A data communication system may require a gradual conversion to cellular, or a permanent mix of cellular and dial-up sites. Each dial-up site continues to use an analog modem connected to the processor, and the modem has a connection to the telephone network. Another analog modem connects to the modemulator at the host site and is also connected to the telephone network. When the host software initiates a connection to a remote dial-up site, it sends a dial command to the host modemulator. The dial command contains the phone number of the remote dial-up site. The modemulator will search for that phone number in its user-programmed dialing directory, but the phone number of dial-up sites are not programmed into the dialing directory, so the modemulator will then forward the dial command to the attached analog modem. Then, if the telephone network is available, the remote analog modem normally sends a ring indication to the remote processor. The host modem may send a confirmation back to the host software, indicating that the connection is proceeding. If the telephone network isn't available, the host modem will send a busy, or no dial tone, or no carrier message instead. Then the remote software normally sends an answer command to the modem, or in some cases the modem may auto-answer. The connection will then complete, and both modems will notify their respective processors. The legacy software can then transfer data bidirectionally. Since the modem system is peer-to-peer, the same steps can occur in the opposite direction when the remote software initiates a connection. If a modemulator site attempts to contact the host while the host is already engaged in a connection with a dial-up site, the remote modemulator will send a busy, or no dial tone, or no carrier message to the processor, just as an analog modem would. Next, I'll explain single-ended operation. A data communication system that has reconfigured or replaced the host software to use Ethernet protocols can continue to use the legacy software at the remote sites if the modemulators are configured for single-ended mode. When a remote site initiates a connection to the host, it sends a dial command to the remote modemulator. The dial command contains a legacy phone number of the host site. The modemulator will search for that phone number in its user-programmed dialing directory that translates the phone number into an IP address and port number. Then, if the network is available, the remote modemulator will open a TCP/IP connection to the destination address, and normally will send a confirmation back to the remote processor, just as an analog modem would. The connection will then complete, and the remote modemulator will notify the processor, just as an analog modem would. The system can then transfer data bidirectionally. This system is classified as client-server, but the modemulator can act as a client or as a server, so the host can be either an IP server that answers connections or an IP client that initiates connections. Finally, a brief explanation of gateway mode. In addition to using a modemulator to upgrade a legacy dial-up system, the same device can be used as a conventional cellular gateway in a system that has replaced its legacy software and hardware. The modem emulation can be disabled by flipping the mode switch located on the Modemulator's front panel. The Modemulator will then function as a standard US Robotics cellular gateway. In this video, you have seen that Modemulator is a cellular gateway that has the same Hayes command line interface that an analog modem has, and that Modemulators can be used to upgrade many types of legacy dial-up data communication system to cellular without replacing legacy software and hardware. To make the Modemulator easy to set up, US Robotics has built a graphical front end that runs on the Windows operating system. Some of the features of this graphical user interface are: on a single screen, view and edit the complete set of parameters, passwords, and banners of a remote or local Modemulator. Save Modemulator configurations to files and recall the files into the GUI dashboard to easily set up more Modemulators with those configurations. Import or export the Modemulator dialing directory as a CSV file. Easily flash new firmware into local or remote Modemulators. Use terminal emulation mode to communicate directly with the Modemulator's command line interface. The Modemulator has many other features and functions that weren't presented in this video. Please visit www.usr.com/modemulator to find more information and to access product documentation. To learn more about using cellular modems and cellular networks for data communication, download the Cellular to Cellular Data Communications Explained white paper from www.usr.com/cellular/C2C. I hope you found this video helpful for understanding how the US Robotics Modemulator can ease the transition from dial-up networking to cellular. Thank you for watching, and thank you for choosing US Robotics.